Generator performance standards are crucial, especially in facilities like hospitals, where a reliable power supply is essential. NFPA 110, the standard for emergency and standby power systems, outlines several critical requirements. Firstly, new generators must be capable of delivering 100% of their rated capacity for the duration of an outage. Secondly, the transfer time from the normal power source to the generator power should not exceed 10 seconds. Thirdly, frequency variation during transfer should be limited to plus or minus 5 Hz. The American Society of Health System Engineers, or ASH, also provides guidelines for health facility electrical power systems design and construction. Their guidelines state that generators should be capable of meeting the transfer requirements as specified by NFPA 110. Furthermore, frequency variation during transfer should not exceed plus or minus 5 Hz for electrical distribution systems. Beyond NFPA 110 and ASH, other standards may be relevant. ANSI or IEE Standard C92.1-2019 offers recommended practices for grounding industrial and commercial power systems. ASHRAE Standard 170-2017 addresses the ventilation of healthcare facilities, which can indirectly impact generator performance by affecting cooling requirements. The low power output and frequency drop observed during the initial load test indicate potential issues with the generator's functionality. The extended transfer time and excessive frequency variation during transfer, even at less than 25% load capacity, are also concerning. It is crucial to verify that the generator is properly sized and compatible with the facility's electrical system. Several steps can be taken to address these issues. Contact the generator manufacturer or a qualified electrician to troubleshoot and resolve the performance problems. Request documentation from the generator company demonstrating that the unit meets the performance standards mentioned above. Consider conducting periodic load tests and maintenance to ensure that the generator is operating as intended. Let's delve deeper into the specifics of these standards and recommendations. NFPA 110 is a widely recognized standard that sets the requirements for emergency and standby power systems. Adherence to NFPA 110 helps ensure that the emergency power system will perform reliably when needed. The requirement for 100% rated capacity ensures that the generator can handle the full load demand of the facility during an outage. The 10-second transfer time limit is critical for minimizing disruptions to essential services. The frequency variation limit of plus or minus 5 Hz is important for maintaining the stability of electrical equipment connected to the generator. Excessive frequency variation can damage sensitive electronic devices and affect the performance of motors and other equipment. AS guidelines reinforce the importance of meeting NFPA 110 requirements in healthcare facilities. Healthcare facilities have unique power requirements due to the critical nature of medical equipment and patient care. AS guidelines provide additional recommendations for designing and constructing reliable electrical power systems in these facilities. ANSI, or IEE, Standard C92.1-2019 provides guidance on grounding industrial and commercial power systems. Proper grounding is essential for electrical safety and for preventing equipment damage. The standard covers various aspects of grounding, including grounding electrodes, grounding conductors, and bonding. ASHRAE Standard 170-2017 addresses ventilation in healthcare facilities. Adequate ventilation is important for maintaining indoor air quality and for preventing the spread of infections. The standard specifies ventilation rates and other requirements for different areas of healthcare facilities. When troubleshooting generator performance issues, it is important to gather as much information as possible. This includes the generator's specifications, the facility's electrical load profile, and the results of any previous load tests. It is also important to check the generator's fuel supply, cooling system, and control system. A qualified electrician can perform a thorough inspection of the generator and identify any potential problems. The electrician can also perform load tests to verify the generator's performance under different load conditions. When requesting documentation from the generator company, be sure to ask for the generator's test reports, wiring diagrams, and operating manuals. These documents can provide valuable information about the generator's capabilities and limitations. Periodic load tests are essential for verifying that the generator is operating as intended. Load tests should be performed at least annually or more frequently if the generator is used frequently or if it is subjected to harsh environmental conditions. Load tests should be performed by a qualified technician using a calibrated load bank. The load bank should be capable of simulating the full load demand of the facility. The results of the load test should be documented and compared to the generator's specifications. Any discrepancy should be investigated and corrected. In addition to load tests, regular maintenance is also essential for ensuring the generator's reliability. Maintenance tasks should include checking the fluid levels, inspecting the belts and hoses, cleaning the air filters, and lubricating the moving parts. A qualified technician should perform maintenance according to the generator manufacturer's recommendations. Proper generator performance is crucial for maintaining the safety and functionality of critical facilities. By understanding the relevant standards and recommendations, and by working with qualified professionals, one can ensure that the emergency power system will perform reliably when needed. Let's expand on the troubleshooting process for generator performance. When encountering issues such as low power output or frequency drops, a systematic approach is essential. Firstly, verify the fuel supply. Ensure there is an adequate amount of fuel and that it is of good quality. Check for any fuel line restrictions or air in the fuel system. Secondly, inspect the air intake system. A clogged air filter can restrict airflow to the engine, reducing power output. Clean or replace the air filter as needed. Thirdly, examine the exhaust system. A blocked exhaust system can create back pressure, hindering engine performance. Check for any obstructions and ensure proper exhaust flow. Fourthly, assess the cooling system. Overheating can significantly impact generator performance. Verify that the coolant level is adequate and that the radiator is clean and free of debris. Fifthly, review the generator's control system. Ensure that all control settings are correct and that there are no fault codes present. Consult the generator's manual for guidance on interpreting fault codes. Sixthly, check the governor system. The governor controls the engine speed and frequency. If the governor is not functioning correctly, it can cause frequency fluctuations. A qualified technician can adjust the governor as needed. Seventhly, examine the automatic transfer switch, or ATS. The ATS is responsible for switching the load between the normal power source and the generator. Ensure that the ATS is functioning correctly and that it is properly configured. Eighthly, review the wiring connections. Loose or corroded wiring connections can cause voltage drops and other performance problems. Inspect all wiring connections and tighten or clean them as needed. Ninthly, perform a voltage and frequency test. Use a calibrated multimeter to measure the voltage and frequency output of the generator. Compare the readings to the generator specifications. Tenthly, conduct an insulation resistance test. Use a micrometer to measure the insulation resistance of the generator's windings. Low insulation resistance can indicate damaged windings. If any of these tests reveal problems, consult a qualified electrician or generator technician for further assistance. Remember that generator performance is also affected by environmental factors. High ambient temperatures can reduce generator output. High humidity can cause corrosion and other problems. Proper ventilation is essential for dissipating heat and preventing overheating. Regular cleaning and maintenance can help prevent environmental factors from impacting generator performance. Load testing is a critical aspect of generator maintenance. A load test simulates a power outage and verifies that the generator can handle the facility's electrical load. A load test should be performed at least annually, or more frequently if the generator is used frequently or if it is subjected to harsh environmental conditions. A load test should be performed by a qualified technician using a calibrated load bank. The load bank should be capable of simulating the full load demand of the facility. During a load test, the technician will monitor the generator's voltage, frequency, current, and power output. The technician will also check for any signs of overheating or other problems. The results of the load test should be documented and compared to the generator's specifications. Any discrepancies should be investigated and corrected. The performance of the generator is also dependent on the type of load that is being applied. A resistive load, such as a heater, draws a constant amount of power. An inductive load, such as a motor, draws a varying amount of power depending on its speed and load. A capacitive load, such as a capacitor, stores electrical energy. Generators are typically rated for a specific power factor. The power factor is the ratio of real power to apparent power. A low power factor can cause the generator to overheat and reduce its output. It is important to match the generator's power factor to the load that is being applied. Power factor correction can be used to improve the power factor of a load. Power factor correction involves adding capacitors to the load to offset the effects of inductive loads. This can help to improve the generator's performance and reduce its operating costs. In addition to the above recommendations, consider implementing a comprehensive generator maintenance program. A maintenance program should include regular inspections, testing, and maintenance tasks. The maintenance program should be tailored to the specific needs of the facility and the generator. A well-designed maintenance program can help to ensure that the generator will perform reliably when needed. When selecting a generator, it is important to consider the facility's electrical load profile. The load profile is a record of the facility's electrical demand over time. The load profile can be used to determine the generator's required size and capacity. It is also important to consider the generator's operating environment. The generator should be able to withstand the temperature, humidity, and altitude of the operating environment. The generator should also be protected from dust, dirt, and other contaminants. When installing a generator, it is important to follow all applicable codes and regulations. The installation should be performed by a qualified electrician. The generator should be properly grounded and protected from overcurrent. The generator should also be located in a well-ventilated area. Once the generator is installed, it should be tested and commissioned. The testing and commissioning process should verify that the generator is operating correctly and that it can handle the facility's electrical load. A detailed commissioning report should be prepared and kept on file. Remember to consult with qualified professionals throughout the process of selecting, installing, and maintaining a generator. Their expertise can help to ensure that the generator will provide reliable emergency power for your facility, and proper documentation is very important. In conclusion, maintaining generator performance standards is critical for ensuring the reliable operation of emergency power systems. By adhering to NFPA 110 and other relevant standards, by implementing a comprehensive maintenance program, and by working with qualified professionals, facilities can minimize the risk of power outages and protect critical operations.